Hello, my name is Soryade, and I'm here to present Lagoon, an analysis tool for open source communities which exists publicly on GitHub. This is work done as part of Galva with my co-author Walt Woods. So the motivation stems from the fact that open source software is widely used nowadays because it is cost-effective and transparent, but increased adoption of open source software increases exposure to supply chain vulnerabilities. Because of the dependency chains that they have, which have led to security bugs and even project failure in the past, as documented by these incidents. So what Lagoon does is that it is a system which can ingest data from different sources. So for example, data from different socio-technical systems which represent open source software communities, which have people who exchange messages with each other, write code which has dependencies within it. All of that can be ingested into Lagoon as a spatiotemporal graph. And then we can run analysis on the data and visualize it and draw inferences from it as required. There is a user interface, a command line interface, and scripts to do these things. In the current state of Lagoon, it contains a 1.5 gigabyte database of the Python and the LXML communities, which have thousands of people, Git commits, pull requests, mailing list messages, and so on. Mailing list messages in particular were in collaboration with the University of Vermont. Right, so the Lagoon database has entities or nodes linked by observations, which have timestamps. So that's where the spatiotemporal nature comes from. And the entire data exists as batches. So each batch can represent a new data source, or it can represent some kind of computation done on the existing data. It is important that these batches are independent of each other, and ingesting a new batch, such as the entire LXML community, takes only a few hours of human time. So to dive a little bit deeper, the blue batch here ingests data from a repository, which creates person, commit, and file nodes, which are linked together by the edges. Then the red batch, which is separate from the blue one, ingests data from a mailing list. This one ingests data from a website, and we have scripts and ingestion modules to do all of these. This particular batch, the fourth one, links the previous batches together by pointing commits and messages to the Python enhancement proposals that they discuss. The fifth batch computes certain toxicity attributes, which is specific to the kind of toxicity analysis that we did on the data, and it links these attributes to the existing entities. And finally, the sixth batch here fuses different entities together, depending on their names and email IDs, whether they match or not. Lagoon also contains a UI. In this case, we are using the UI to do a certain kind of analysis, which is find out files with the fewest unique maintainers. So we can get any node ID and visualize it using the UI. Clicking on a node gives all the details about that node. In this case, it's a person. Clicking on the neighbors of the node gives the entire spatiotemporal graph which surrounds a node. We can filter the visibility of that graph according to time. The triangles here represent files, the blue squares represent commits, and we can click on any one of them to view additional details about that. So in this case, we can click on this commit and see that it changed a couple of lines. So that's how the UI works. And finally, we can also use standard SQL queries to interact with Lagoon and derive different kinds of analysis. That's all. Thank you.